Hey everybody, we're back simplifying square roots, and we left off in our last video at example 2, so we're going to pick it up with example 3 today. So let's take a look at what it says. Given the expression 2 times the square root of 11x, which value of x, and here are your answer choices right here, this is a multiple choice problem, which value of x makes the expression equal to 6 square root 11. So we want to find out when this expression equals this expression, and we want to know which one of these do we fill in here for x to make that happen. Okay, so let me do it sort of the way I'm not supposed to do it. Let me do it on the TI 84. This is kind of a clever approach, I think. What I'm going to do is one by one, I'm going to plug these values up here for x. Then I'm going to plug this into the calculator, get a decimal. And then I'm going to plug 6 square root of 11 into the calculator and see when they match. So let's test out letter A. If x is 49, then this expression is going to give me this. 2 square root of 11 times 49. So let me punch that in. 2 square root of 11 times 49. And I'm going to hit enter. And I'm going to get 46.433 if I'm rounding to thousands. Okay, now let's go over here. I want to see if that equals 6 square root of 11. So I'm going to type that in. 6 square root 11. 19.8997. So I'm going to say that's 19.9 with all those 9s in there. They are not equal, so I know A is not my answer. Okay, let's go ahead and test letter B. I don't have to punch 6 square root of 11 in again, because I already know that's 19.9, but I will have to put my new x up into this expression. So let me do that. So that would be 2 square root of 11 times 9. All right, let's put that in the TI here. I'm going to clear that out. 2 square root of 11 times 9. Bingo, it matches. There it is. So I'm done. Letter B is my answer. Now, up above it said don't use a TI-84, so I kind of cheated there. Let me show you how I would have known 9 was my answer without using the TI-84. Here I am, and at this point right here, I had not used the calculator. I just simply plugged 9 in for x, so this is legal right here. And if you think about what we did in the last video, what I could do is bring the 2 down, and I could split this multiplication into 2 different square roots. So I could write this as the square root of 9 times the square root of 11. I just used the commutative property of multiplication to flip those around. 11 times 9 is 99. 9 times 11 is 99, so it's legal to switch them. Now, the square root of 9, we know from our perfect squares list, is 3. So I'm going to break that down and write this as 2 times 3 times the square root of 11. And since 2 times 3 is 6, I've got 6 square root 11. And that certainly matches this, which is what we were supposed to find. So that's 2 different ways you can think about that problem. Okay, let's go on to example 4. This is our final example. It says, given the expression, the square root of 123x, for which value of x can the expression be further simplified? Okay, so for which value here of x, when we put it here, can we simplify further? All right, now this is going to take a little more work. So I've actually written this problem out on a separate sheet of paper. so I have some more room to work underneath. Okay, so let's think about this. In order for a square root to break down, there needs to be a perfect square underneath the root. In other words, let me find my perfect squares list. I've got to get one of these numbers, one of these perfect squares under this root so that I can break it down further. Now, I know 123 is not a perfect square, because if I would keep going with this list, if I did 11 squared is 121, and 12 squared takes me to 144. If 123 was a perfect square, it would sit between here and here, and it's not there. So I know that just sitting here by itself, 123 is not a perfect square. I also know that none of my answer choices are perfect squares. 23 is not on my list if you look. Nope, 23 is not there. 42, nope. 17, nope. And 11. None of these are perfect squares. So here's my thought process. If I plug 23 in for x, I'm going to have this, the square root of 123 times 23. And that's not going to go anywhere. Neither of those is a perfect square. If I do letter B, I'm going to have 123 times 42. Neither of those is going to go. If I do 17, 123 times 17, nope. And if I do 123 times 11, I have no perfect squares. So you might think, well, none of these work, but actually one of them does. So I have to think a little bit further. Well, I can find my factors of 123, just like I did on the other problems. And then maybe I could see if any of these numbers have a factor in common with that. Okay? So let's write out the factors of 123. Now, I don't even know them very well myself because it's kind of an odd number. So let me start with my calculator. I'm going to start doing that division strategy. So if I take 123 divided by 2, nope, it's a decimal. 123 divided by 3, 41 times 3, okay? 41 times 3. Let me do 123 divided by 4. Nope, 123 divided by 5. No. Let's see if I can get some light on here. It's not the easiest to see. Oh, look at that. Isn't that better? 123 divided by 6. 123 divided by 7. These are all decimals. 123 divided by 8. Decimal. 9. 10. This isn't looking too promising. 11. Okay. Truth of the matter is, you could keep doing this. The only pair you're going to find for 123 is this one, 41 times 3. So let me replace the 123 with this pair, 41 times 3. So now it's going to look like this. 41 times 3 times 23. So I'm bringing him down. This one just got split into 41 times 3. This guy right here, 41 times 3 times 42. This one, 120, no, not 123. Sorry, 41 times 3 times 17. And this one, 41 times 3 times 11. Okay, now my only hope is if somehow I can break 23, 42, 17, or 11 down into something with either a 41 or a 3. So if you look, all of these, 23 is a prime number, 17 is a prime number, and 11 is a prime number. So they are only divisible by themselves in 1. So 23 is not breaking down to anything, 17 can't break down to anything, and 11 can't break down. So we're stuck. This is done, and this is done because you don't have any perfect squares under there. But 42 is a little more interesting. If I think about either of these numbers, does 41 go into 42? No. Does 3 go into 42? Well, let me check. 42 divided by 3 is 14, so it does. So 14 times 3 can be my 42. So now I have 41 times 3 times 3 times 14. This guy right here, 3 times 3 makes a 9. So now I have, let me come down here. So now I have the square root of 9 times 41 times 14. And 9 is on our perfect square list. The square root is 3. So I can break this up to the square root of 9 times, keep the bad stuff under here. This is the stuff that does not break down. Neither of these is a perfect square. The square root of 9 we know is 3. We'll bring that out. And underneath the roof, we'll leave this. And I will just take 41 times 14, get 574. So here is my final answer. This is the simplified version of this. And the number for x that worked was letter B. Okay, so that's a little bit more complicated. A lot of thought has to go into that one. Okay.